Good morning, everyone. I am Dr. Gaurav Sahu, Assistant Professor, Department of Mechanical Engineering, SIRT Bhopal. Today, we are here to learn about how to draw bending moment diagram or how to find out bending moment values. We have already discussed on shear force value. So now, for the same beam, we will be going for drawing bending moment diagram. It is a part of strength of material, mechanical engineering, third semester. So let us start again with the same beam that we have chosen for the shear force diagram. A beam is simply supported, having support at A and B, carrying UDL 20 kilonewton per meter, 10 kilonewton point load. By taking moment about B, as per the method of fixing the B point and applying the forces in a relevant direction, is that upward force RA will be turning the beam or a stick in upward direction against this notation. So it is minus RA. And when you're converting this force into movement, you have to multiply it with the perpendicular distance. So perpendicular distance of this beam is 4 plus 4 plus 8. So RA into 10. Point load 20 into 4 converted into point load. UDL is converted into point load. Then the midpoint distance is 2, 4, 6 and 2. So total distance is 8. So 20 into 4 into 8 and 10 into 2. So this we have taken the moment about point B. And the same thing we have done in SF problem also. We have calculated the value 66 kilonewton RA. And as per equilibrium, RA plus RB is the total upward force is equal to total downward force. So upward forces are RA plus RB and downward forces are 20 into 4 because whensoever UDL is there, you have to convert that UDL into point load by multiplying with the distance for a span over which the UDL is floated. So UDL 20 kilonewton per meter is floated over a span of 4 meter. And generally, um, this method is applied to convert UDL into point load. So by putting the value RA is equal to 66, we are having the value of RB 24 kilonewton. So this is all about the value of RA and RB. So here students, we have calculated the value of RA and RB. So now we will be going further. This notation is only valid for calculating the reaction forces. Now, when we go to next slide, is that calculating the value of bending moment only. So remember that we are calculating the value of bending moment only. We have already calculated the value of shear force diagram. So completely this question is a part of shear force as well as bending moment diagram. So in our earlier lecture, we have discussed about the shear force drawing. Now we will discuss about the finding the value of bending moment and bending moment diagram. So we will follow this notation is that on the left side of the section, the couple going in clockwise direction is positive, and on the right side of the section, the couple going anti-clockwise direction is positive. So starting with creating a section, the theory of creating the section is similar as per the theory of shear force, is that between two loads across a UDL or two supports or support or load. So here a UDL will fix a point as a standard reference point as we have done in shear force. We don't for a particular question. The sections for shear force and the section for bending moment are always same. Whatsoever the section is taken for the shear force, the same section will be followed for bending moment. So I am taking this lecture in two different parts, but the answer will be a single question for both shear force and bending moment. So the section will be same xx1 and the distance of this section from fixed reference point will be small x. BM value for AC segment is that xx7 section will be, now it is something important. So here we will take all the moments about the section x1, x1. RA is upward direction and the perpendicular distance is x. So according to this notation, RA x will be positive. Now 20 kilonewton per meter floated in the span of x. So 20 into x. Here we have converted the load into point load, but now it is applied on the midpoint of this segment x. So the distance of this midpoint from the x1 section will be x by 2. So x by 2 will be here, which will be a perpendicular distance. Okay. So this point load will be multiplied with the half of distance of x. So here we have inculcated the equation for bending moment for segment AC x on x1 section. Now apply the limits as A is a reference point, so here x will be 0. And moving toward the right, the value of C is will be 4. So by putting x is equal to 0 in the above equation is that this equation, the value of BM at A point will be 0 kilonewton meter. And applying the limit x is equal to 4 because C point is at 4 distance from the reference point. So we will be having BMC is equal to 104 kilonewton meter when we are putting x is equal to 4 in the above equation. So this is all about the segment 1, is that segment AC. Now we will move further for creating the x2 x2 section in the part CD because we will be going towards right. So after considering this AC portion, we will be going toward this portion. Here one of the load is here and one of the load is here, so it is very much efficient to draw the section over here. X2 x2, its distance from the fixed point will be x. Fixed point is always same, remember it. X2 x2 section CD. Now how will you make BM equation for this point? RA above, total distance is x, moment is like this, positive sign. 20 into now 4 because we are considering left of this section, complete section. 20 into 4. Now this 20 into 4 is applied at the midpoint of 4. Okay. So the distance of midpoint is that from this portion to this portion is that you will have x minus this portion. So this portion is half of the 4 is the 2. So the distance of point load 20 into 4 from this reference point will be x minus 2 because x is total distance and 2 is from here. So when you deduct 2 from this x, the remaining will be this portion. So that's why it is x minus 2. And if we apply the limit at BMC, x is equal to 4. In the above equation, you will be getting the value 104 kilonewton. And for BMD, D is equal to 8. So by putting the value of x is equal to 8 in the above equation, you will be getting 48 kilonewton. Now let us move for the section x3, x3 in segment DB. Total distance of this section from the reference point A is x, small x. Shear force value for DB considering section x3, x3. BM equation will be RA going upward. Total distance is x, so Rx 20 into UDL4 applied at the center of this 4. So here the point load converted 20 into 4 will be applied. But as you see, the total distance is x and we have to deduct this x2. So again, x2 is multiplied as a member of perpendicular length. Okay, here x2, distance of x3 to this point load will be x minus 2. And for 10, it is again downward, but the total distance is x. So we will deduct x minus 4, and minus nothing. So x minus 4 will be x minus 8. So here the total distance of this segment from the section x3, x3 will be total x minus these two 4 members. Okay. So 10 is equal to x minus 8. So this is very difficult thing to calculate the distance of section. So be very much visual when you are calculating the distance of the load from the section. Like here it was x minus 2 because x is total distance and 2 is this portion, midpoint portion. So you are getting x minus 2 in the similar way, x minus 8. Okay. Now putting the value of BMD is equal to 8. In above equation, you are getting 48 kilonewton and BMB is equal to 10x because the total distance of point B from A is 10. So putting the value, we are getting 0 kilonewton. So this is all about calculating the values. Remember the values because it will be helping us in plotting the BM diagram. So for plotting the BM diagram, you don't have to draw directly over it. You just have to fix the values. Is there 0 kilonewton at point A, 104 at point C, 10, sorry, at point D it is 48 and at point B it is 0. Now the main task in BM diagram is generally which kind of line will be there. It is the nature will be a straight line or nature will be of a curve. So always remember if the equation is in a higher quadratic order is that of higher power order is that of square cube. So you will always draw a curve. But when the equation is of linear order that all the x's are without any power or the power 1. So the ruling line will be of straight line nature. So you can see that in the AC segment, it is of nature square So the curve is inculcated, and in CD and DB it is of linear nature. But here comes the concept of zero shear force. As I have already discussed in SFD diagram, whensoever the point of zero shear force is considered, so at zero shear force, the bending moment is always maximum. So as per this diagram, calculate the value of x. By measuring the value of x, you will find that the value is 3.3 meters. Now, in such cases, you have to very much visual in drawing the SF diagram. You have to draw it according to the scale, like 4 meter. You can't draw on the copy, so you have to draw like 4 meter is equal to 4 centimeter or 2 centimeter, where you will consider a scale of 1 meter is equal to 1 centimeter, or 1 meter is equal to 0.5 centimeter. So this will be the easiest way to calculate the value of x, is that 3.3. You will put this value in the segment AC's equation, is that this equation, first one equation. Now put the value of x is equal to 3.3. You will get 108 value, which is the highest among all the values. So that's why it is said that at the zero shear force, the bending moment is higher. So here you can see that I have taken x.3, x3.3 distance, where I have plotted the 10.8 kilonewton meter value and draw the curve like this. So this is all about bending moment diagram. This whole question is a single question. Calculate the value of shear force and bending moment diagram that I have picturized in two different videos. So firstly, you have to calculate the shear force diagram. You will draw like this, and then this diagram will be plotted below this diagram. So generally, these kind of questions come with the collaboration of shear force and bending moment. So after drawing the shear force diagram here, you will draw this diagram below just here. Like 0 kilonewton will come in the symmetry of 66, 104 will come in the symmetry of 40, 48 will come in the symmetry of 24, and 0 is coming in the symmetry of 24. And keep remember that at the point of zero shear force, there will be a maximum bending moment, which is very necessary for properly plotting the VM diagram. So whensoever you want to draw a proper VM diagram, you have to find the value of zero shear force if is in picture like this. Okay. So thank you very much. This was all about the our